Pandya from Business Communications. Today we are going to discuss about the hydraulic bench, Ronald's number and water jet. Before I start the discussion on the system, it is important to understand what is the use of the equipment and what we are going to do. Okay. And throughout the training, first I will start the training from the hydraulic bench. We will discuss what is the hydraulic bench and what is the application and how we can use this hydraulic bench to our experiment. And second, we are going to discuss about the water jet. What is the application of the water jet and how we can use this water jet for our real life calculations. And third is the Ronald's number and what is the application and how we can use this apparatus in our experiments. First, about the hydraulic bench. The hydraulic bench is the mechanical equipment which can be used for the different purpose. It might be like the water jet here, it might be used for the Ronald's number apparatus. If you are discussing about the system have the mainly three parts. One part, this is called the whole frame of the body, and the second part, this body is connected with the pump downside. This is called the centrifugal pump, and this centrifugal pump is connected in the top side so that we can take the input water for using our applications. And the downside, there is a drain point to drain the solution. For the solution, we are using the water because our all experiment we are going to use the solution as a water. Next, if you are discuss about the systems specification, then first is made by the ISOM company. Second point, if you ask about which kind of pump we are using, then it's a centrifugal pump and the power rating is the 0.37 kilowatts and flow rate we can use for the maximum 80 liter per minute. And the storage tank, you can use the storage tank 165 liter for our experiment purpose. Next, about the description of the system, how we can describe the system in each part. First, I am going to start from the right side. The downside, this downside is called the storage tank. We can store the water for our experiment purpose. Next point is here we are going to put the water from this point. Next, we connected in the same level, we connected the centrifugal pump, and this centrifugal pump can be used for sending the water in the top directions. And here we are using this flow control valve according to our experiment, how fast and how slow you want to apply the water to your experiment, then you can adjust by help of these knobs. And this second one is called the control unit. This have the two switch. One switch is called the circuit breaker and second switch is used for the running the centrifugal pump. Then we need to understand what is the importance of these two switch. The two switch, first just we giving the power, and second switch, suppose in case of any earthing problem, in case there is some overload to the system, or some fluctuation is coming, the automatically the circuit breaker is getting tripped just for your safety purpose. And suppose if any student is doing some electrical problem, so for example, then automatically the ground voltage will be increasing and they automatically it will get down, right? The system will be shut down automatically. In the top side, we can put the level adjustment point. We already supplied the level adjustment point. By help, we can understand what is the level of our hydraulic bench. We generally for the good measurement, we always check like this hydraulic bench should be placed on the smooth level. It should not be some angle and not should be tilted. Otherwise, it will affect our measurements. And the downside is called the measuring depth. When we are using the water from the downside, and this water going to store in this measuring depth have the one scale. Suppose if you are doing the experiment for the 10 minutes, 20 minutes, then you can make the calculations that suppose in the 10 minutes that much water we are receiving in the tank, then what was the rate of the flow of the flow of the water from the centrifugal pump, and after that during the calculation we need to calculate what was the mass flow there, because we know that there is a relation between density, mass and the volume, and after that this volume is going to require for the calculation in our experiments. Okay. Then the same point, the before it was the color imaging, but same here, just they are giving the one block module to understand for the student how we are doing the block module. The somewhere for the student it's very convenient to understand by the block module rather than the color image. But there is no difference in between the last image and this image. The same image here, like a storage tank and connected with the pump. Then going for the this flow control. After that we are using the water from here and we are using to the our experimental setups. Next, the previous you already discussed about the hydraulic bench. Next, the experiment point is called the water jet impact. Now we are going to discuss about what is the water jet impact and how we can use this water jet impact in our real life. In the real life, you can see in the many places the water jet application are using. Maybe we can see from the water jet. Sometimes they are using to swim on the water layer because they are creating the strong forces on the layer of the water. After the people start floating on the surface of the water. Okay. Then if you define this apparatus in the term of the definition, then we can say that this water jet apparatus is the mechanical device which we can use to calculate how much this water flow is impacting the force on the receiving object. And during the experiment, we have to calculate during the flow rate how much force they are creating to the object and how this object is going to the up direction. And throughout the experiment, we are going to calculate what was the impact, how much the momentum is getting changed. There is the standard calculations which we will discuss in our next slide, how we are doing the calculations. If we discuss about the specifications, first the manufacturer name is the Isham Company Limited. Second, about the cylinder diameter. If we are discussing about the cylindrical diameter, that is 150 mm. Because sometimes there is one more formula. If you are doing deep physics, then by help of this diameter and the shape of the object, you will be able to calculate how much maximum volume they can come inside if you are using the water and any liquid. Then sometimes the cylindrical diameter is also required, but our approach will be different during the experiment. Our approach, it will be like we are going to apply the water and we are going to monitor by help of the stopwatch. And we are going to see that after 10 minutes how much water is coming. Next, if we discuss about what is the nozzle diameter, because the nozzle diameter is required to calculate what is the cross-sectional area, and we know that the volume is depend on the cross-sectional area and the height. Then you can able to calculate the volume of the nozzle. If you discuss about the target diameter, then is 36 mm. Because we know according to the target diameter, the water will be split according to the shape and according to the width on the objective side. Next, if you are discuss about the overall point of the system, how we can define and how we can understand. Now we start from the downside. Downside, we are going to insert the water from here, and there are different kind of target we are going to use. We are going to basically use the three kind of target. One is called the 120 degree outwards angle, one is the 120 inwards angle, and other the flat surface. Okay. Then first we are going to use the water inlet from here, and this is the nozzle part, and the nozzle they will apply the water to the object. After that, when according to the change, apply the force of the flow of the water, then this object it will be moved. Yeah, it will be going down according to the applying weight on the top. Yeah, according to the applying velocity of the water from the downside. And the downside during the process, the water, there are 2 points for the discharging the water. Your experiment will be continue and you can able to see downside the water is going to discharge from the bottom of the your apparatus. This is the basic diagram and basic understanding about the system. Even we are going to discuss same thing on the equipment side. Okay. Here, like there are some standard experiments, but you can create the more than that experiment. This is called the number of cases. And sometime what I saw in other university, they have the already supplying the 3-4 experiment, but teacher making the more experiment in case that the more student or divide the experiment. Okay, then what can be the standard our experiment? First we need to calculate what is the flow rate and how we can calculate. We'll discuss during our experiment. Next about what is the velocity, because we have to finally our objective to calculate the impact of the force. Then without calculating the velocity of the water molecules, water mass, we cannot able to calculate what is the impact force. Then we are going to calculate the one experimental impact and one is the theoretical impact. After that we have to take the difference. This is my the theoretical impact and this is the experimental impact. Then you have to take the differences. Then you can understand that much error we are getting according to the theory and after doing the experiments. These are the 3 experiments in the back side of the paper. They given this experiment with the examples. The all values given just for the support of the student and teachers. Next, if you discuss what is the physics behind it. Like if you discuss like how the physics is working, then suppose this downside is the initial velocity is v0 and the velocity moving. Then when they hit this water, when they hit to the object, then definitely this water will be aspirate according to the receiving angle. Then we know by the vector quantity, this is the according to the vector quantity, we can add the 2 components. One is called sine theta. Another is cos theta. In these directions, we are going to use this component, the effect of the component, it will be v cos theta. But now we cannot use the other component because our impacting velocity in the similar direction. Then put on the respect of this velocity, the other direction velocity is considered as a 0. The next, if I discuss about what is the force according to the formula, then suppose if I multiply here with respect to the mass of the water mass with the velocity in the top side, if I make the calculations, then the initial and the difference of the final minus initial, then you can get the change of the force, and this change of force is called the change of impact during our process. Next, just I mentioned the name. This is called the mass of the water mass, and second is called the initial velocity, and the other is called the final velocity. Next, one more point we need to discuss. Suppose just I am applying the simple here, the basic formula v square equal to u square equal to v square minus 2gh. Here we are just applying a simple formula of the most state motion. Then we can able to get the final velocity, and you can make a small calculation during the process. Okay. It's okay? Okay. Okay. Now we are going to discuss about the similar to the Reynolds number apparatus. What is the applications? The same. This is the setup, and Reynolds number basically it's used for the calculation of the different kind of flow. Like it might be linear kind of flow, yeah, it can be turbulent kind of flow. But when any water molecule or other liquid, when they are flowing from one point to other point, due to the property of the viscosity, the molecule is getting disturbed according to the internal pressure. Then in the chemical, in the process industry, like they are using this calculation to understand which kind of flow we have to use here. If you discuss about the specification of the system, then this is also made by the Isham company, and the cylinder diameter is 150 mm. and what is the pipe diameter inside which we are using to make the calculation of the which kind of flow inside, either laminar flow, linear flow, or turbulent kind of flow. Then this diameter is 130 mm. Next, about the description of the systems. Description means this is the overall system. We are going to apply the water in the top side of the object. Here we are going to use the one a small object so that a smoothly flow will be happen from top to downside, and downside we are going to receive the water. In between we are going to add the other some color, show the transfer error, the one color from the top side, so that we can able to see that how kind of flow is happening in the one experimental part. Then just mentioning the name of the part. This is called the dry reservoir. You can use the your color also, might be red, blue, any kind of color you can use, and you can understand which kind of flow is happening in the experimental pipes. Okay, here we can understand what is the meaning of the laminar and transfer, like the turbulent kind of flow. Suppose if there is the here, suppose it's a liquid pipe when we are using the liquid, and suppose I am adding the one other kind of liquid here, then this liquid will be a start flow. Suppose there is no disturbance in the flowing of the liquid, then we are going to get the linear flow with the liquid. This kind of flow with the other liquid is called the laminar flow. In case of the some turbulence, like suppose the water molecule is running very fast and they creating the turbulence, then the other liquid, there will be not constant flow and they will get disturbed during the flow. That time we call the turbulent kind of flow. Linear means just they will flow with according to the other liquid, they will just go a step, and turbulent means they will get disturbed in the straight line moving positions. Now if we discuss what is the definitions and how we can using the formula. There is one the standard formula is calculated by the Ronald. He was